All right, so let's begin. So first thing first, how to differentiate. Right, we start firstly with differentiation. Right, nice simple principle. First thing you do in differentiation, suppose I gave you y is equal to ax to the power of n. The general way to differentiate, you can write it like this, the change in y with respect to x, or you could write it like this, y with a little prime, right? You take your ax and you minus. So you take your ax to the n, right? You minus 1 from the power, right? And you multiply. Hold on, no, I want to add in this person here. Right, sorry. Right here. So as I was saying, to differentiate, you bring down the power, which is n, and then you multiply by, you just minus 1 from your new power, right? For example, if you have y is equal to 5x cubed, right? The differential of 5x cubed, you bring down the 3, you write back the 5, and you minus 1 from the power. So you'll get 15x squared. Okay? So you'll get 15x squared. All right? If on the other hand, I gave you something like this, y is equal to 6x. Remember, 6x means 6x to the power of 1. So the differential of that, you could bring down the 1, write back the 6 and minus 1 from the power. So you'll get 6x to the power of 0, which is the same as 6. So in short, the differential of 6x is just simply 6. That's okay? What about if I gave you a constant now? Are you okay with that? Right? If I gave you a constant, y is equal to 6, there is no x term, right? There is no x term, which basically means that the differential here is 0. Right? It's simple reason as this. 6 is really 6x to the power of 0. You bring the 0 in front, you'll get 0. Right? But basically, if you differentiate in constant, you'll get 0. All right, so you bring down the power, you minus 1 from the power. Right? That's basically how you differentiate. Right? The differential of a constant is 0. The differential of 6x is simply 6. Copy down. Let's go again. Right, I'm going to go a little bit fast because the objective today is to cover both of them, right? I'm going to go a little bit fast. Right, number 4 now. Suppose I combine them together. Suppose I give you y is equal to 5x squared minus 6x plus 2. How are we going to differentiate it? We do them one by one, right? What's the differential of 5x squared, Shivis? What's the differential of 5x squared? What is do? Bring down the power, which is 2. You write back the 5, and then you minus 1 from the power. That's okay? What did I do again? I bring down the power. Hey, you listening? The steps is what? Bring down the power, write back the 5, and minus 1 from the power. You see that? What's the differential of 6x? Ashavish? What's the differential of 6x? Sorry, minus 6x. What you do? Right, just right by this. What's the short way? Just take off the x. What's the differential constant? So it's 0. I just showed in the last example. The differential of 2 is 0. So you'll be left with dy dx is equal to 10x minus 6. Try this next one. Try that fast. Shavish, go talk. Hurry up. I want to get all this right. You should come in front of me. You should come in front. I want to see it do all of this. To what? Shavish, hurry up, hurry up, hurry up. Anybody get in trouble? Alina again, sure? Sure. Come like people online work it out and type out the answer. They work it out. I'm sure they work it out. Shabish, you writing a question as well? Right, so you should get dy dx is 3 by 4, that's 12, minus 1 from the power, that's squared, minus, bring down the 2, 2 by minus 2 is 4, minus 2. Nia, you got that? Next one, number 6. Right, I'm going to show you, well, am I going to show you 2 ways, right? Yeah, how about you? I'm going to show you our next type. Actually, do one more for me. Two by the square root of x. Differentiate that, please. I would like back my answer with a square root. Huh? Go ahead. You differentiate that. All right, let's see what you got. So you have y is equal to 2x to the power of a half. Right? Square root means to the power of a half, right? So therefore, dy dx is equal to, bring down the half, write back the 2, and minus 1 from the half. So you'll get, sorry. So you'll get a half by 2 is 1. So you'll get 1x to the negative a half. But I don't want the answer like that, right? I want back the square root. Negative means what? 1 over x to the half, which is 1 over the square root of it. All right? Next one. Next one. What number is it? 7, 8. Right, forget that. I'm gonna give you our next type. If we have to differentiate something like this, ax plus b to the power of n. right? To differentiate that, what's the steps up? Bring down the power n, right? That's step number 1. Then differentiate inside the bracket. What's the differential of ax plus b? A, right? That's step number 2. Step number 3, write back whatever in the bracket. And step number 4, minus 1 for the power. For example, if I gave you y is equal to 5x plus 3 to the power of 4, you can't expand that out. So you have to follow the steps, right? dy dx is bring down the power, differentiate 5x plus 3, you'll get 5. Write back the bracketed term and minus 1 for the power. So you're going to get 20 by 5x plus 3 to the power of 3. Please do not try to multiply 20 by 5, right? Because remember, quad mass, you have the brackets first. So you have to cube it first, right? So that is your shortcut method. I'm going to show you something called chain rule. Actually, wait, I won't show you chain rule. I'm going to give you one more like this. I want to make sure should be here this right. Copy it down. Should be so watch it back here, right? I'm going to show you back. Right? Watch it here. So the first thing you do is you take the power and you bring down the power here. Right? Then you differentiate 5x plus 3 and you'll get 5. Then you write back whatever you had in the bracket, which is 5x plus 3. And then you minus 4 from 1. Right? Yeah. Okay. So once you remember the steps, try this one here. Y is equal to 3 plus x to the power of 5. 3 plus x to the power of 5. Right, take your time, do all the steps. Ready? Alina, you got it? Sure. Go ahead. Bring down the power. Right, then yeah. Then yeah. Right, that's it. So it's 5 by 3 plus x to the power of 4. Right, again, don't multiply this out, right? Don't multiply it out. Right, you must do the brackets first. One more. One more, since all I get all right. Try this. Square root of 2x plus 1. Take your time. Square root means power over half, right? If I give you the answer in a square root, I want it back in a square root, right? Yeah. All right, let's see. Let's see what you have. Remember, square root means 2x plus 1 to the power of a half, right? So we can differentiate, bring down the half, differentiate inside the bracket, write back the bracket, and minus 1 from the power. So a half by 2, that's 1. So it's 1 by 2x plus 1 to the negative a half. Since it's negative, we could turn it into a fraction, 1 over the square root of 2x plus 1. All right? Yeah? So that's one way to do this. The next way to do it is something called chain rule. All right? Copy it down if you didn't get it. Right, so let's take a look at chain rule here. Right, what is chain rule? Well, chain rule is a different way to find dy dx, right? If you make a little substitution, right? So chain rule looks like this. Dy dx is equal to dy du multiplied by du dx. So in chain rule, we have a new variable u. So I'm going to show you. Right, so I want to show you an example of how to use chain rule, right? Suppose you have 2x minus 1 is to the power of 5. And I want you to differentiate this. And let's say you have to use chain rule. Then you're going to have to make a little substitution. So you can let u equal to whatever in bracket. So that means now when you differentiate u, you will get du with respect to x. So the differential of 2x minus 1 is equal to 2. Right? Watch it first before you write. Watch it first, right? So du dx 2. Oh, sorry, remember this was y, right? So y is equal to taking off 2x minus 1, and I am going to write u. So y is equal to u to the power of 5, which means that we can differentiate y with respect to u. And you will get 5u to the power of 4. Okay? Now for the long part. Right? Now for the long part, we're going to use the formula. We're going to use dy dx is equal to dy du multiplied by du dx. Right? So dy du, that's right here. Dy du is 5u to the power of 4. Du dx is right here, multiplied by 2. So your answer is 10u to the power of 4. But you can't leave your answer like that. You have to replace u, and you write in 2x minus 1 to the power of 4. That's it. It's a long way for the shortcut method I showed you before. Right? It's a little bit long. Right? So basically, you're replacing this here with u, and then you're differentiating this, and you get 2. Then take off 2x minus 1 and put u, and differentiate y in terms of u, and you will get 5u to the 4th. Then put dy du here, put du dx here, and multiply it out, and you're done. Go back in u after. It's a little bit long, but if a question says use chain rule, then you have to be able to use this rule. right? Chain rule is supposed to give you the same answer as the shortcut method I showed you a little while ago. Try number 2 using chain rule. Right? Whatever in the bracket is u, right? So I'll just help you out here. Let u be the part in the bracket, 1 plus x. Take your time, right? Let u equal to find the u dx, find the y du. Not the shortcut method, huh? Use chain rule. Right? So finish. All right, let's check it out. So du dx is equal to 1. Right? Y is equal to 5u to the power of 3. So it means that dy du is 15u squared. Right? So you're applying the normal differentiation. And then we're going to use the formula dy dx is equal to dy du multiplied by du dx. So you're getting 5u cubed or 5 by 1 plus x cubed. Okay. You only have to use chain rule if the question, wait, someone went wrong there. All right, on the wrong thing, 50. And? Yeah, sorry, I went the wrong thing. Sorry about that. Right, you only use chain rule if the question tell you have to use chain rule, right? Otherwise, you could use the shortcut method, right? If the question says to use chain rule, then you have to use it. Otherwise, you can use this technique here, right? Okay, so that is your chain rule. Next one, differential of trigs. Differential of trigs. All right. Let's do the trigs and then I'll show you. Yeah, don't worry. Quotient rule and product will come in. They are coming. What I was saying there. Right. Next, I just want to show you how to differentiate trig function quickly. Real easy. Number one, if I give you y is equal to sine x, then dy dx is cos x. If I give you y is equal to sine x, sorry, cos x, the differential of cos x is minus sine x. Okay? And you're good to go. Right, here's what you can do for me now. I am going to ask you to differentiate y is equal to cosine 5x. And I want you to use chain rule. I would like you to use chain rule. Right, since it's the first one, I'll help you out with the first part. Let u equal to 5x. Right? Try and see if we can use chain rule there and find the differential of cos 5x. Right, so I told you was u already. If we get trouble, don't worry, I'll show you that now. I was giving you a few minutes. Let's just see how it looks. So you have u, so you should know what's y, and then you should be able to differentiate it, right? So you should have u, which is du dx is 5. That's okay? Yeah. What would y be? Cos u. Nice. So what will be dy du? Right, minus sine u. Good. And now we could use the formula. So dy dx is equal to dy du, which is minus sine u, multiplied by du dx, which is 5. So that's minus sine u, or you could write it like this, minus sine 5x, right? The question was in x, so you have to give them back in x because we asked for dy dx. That's okay? Same. Next one, just one more. Right, use chain rule. Did I show? Oh, sorry, I forgot to show you the shortcut. What you say? So there's a shortcut to differentiate this. Here's how easy. Differential of 5x is 5. Differential of cos minus sine. Then you will write back the 5x. That's it. Right? Differential of 5x, 5. Differential of cos minus sine. And then you will write back the 5x. And you're done. Right? That's the shortcut method. Try number 2 here. Shamina, Waka waka yeah. Yeah, take some to what's up the brain a little bit. Try number 2 and 3. Number 2 should work out. I saw it in pure maths already. So. All you can do that about. Yeah, both the chain rule. 2 and 3 chain rule. Shamina. Yeah, man, it should work out. I hope for the best. I remember seeing it somewhere. I feel pure maths. Take your time. Try number 2 and number 3. Huh? Do I touch it for nothing? You chain rule, no shortcut thing. You chain rule, you will always want any bracket, right? Time you chain rule, follow the steps. Which one? No? Yes, your file can reach. I hope it work out. Which one? The second one? Yeah, I hope it work out. Let's see what you got. So let's check out the first one. So let's let u equal to 2x plus 1. And even if they don't tell you what is u, it's generally what's in bracket, right? Du dx is equal to 2. y is equal to sine u. So dy du is equal to cos u. Nice. So now what is dy dx? Dy dx is dy du, which is cos u, multiplied by 2. So it's 2 cos u or 2 cos 2x plus 1. That was easy, right? All right, let's check out the next one here. So we could let u equal to cos x. So du dx is equal to negative sine x, right? du dx is equal to negative sine x. And then y is sine u. So dy du is equal to cos u. So therefore, what we're going to do now? All we could do is this. We could say that dy dx is equal to cos u multiplied by negative sine x. What we could really do here is write cos. U is what again? U is cos x. So it's cos x by sine x. Leave it like that. Don't go any further and do cos by cos something because it's not the same thing. It don't matter, it's a product. I just put it on the outside. Right? I just put it on the outside. Right? So you can leave it like that. Cos of cos x by sine x. I can simplify, but don't worry with that. When you do pure maths, you will do that. Pure maths. No. Huh? No, not the same thing. Right, number 2, number 3, good. So we can differentiate sine, we can differentiate cos. That's it for trigs. One more rule, product and quotient rule. Had a product rule, quotient rule. Had a product rule and quotient rule. Okay, so product rule is whenever you have to find the differential of y and you have two products, u and v. Quotient rule is when you have two quotients, u over v. Okay, so if it's product rule, you're going to write dy dx is equal to u dv dx plus v du dx. Quotient rule looks like this. Dy dx is equal to v du dx minus u dv dx all over v squared. Okay, so I'm going to show you how to do both of them. What's that? All right, so watch here. First thing first, you all see the product there? 2x plus 1 multiplied by cos x. You all see that? Should be seeing that. No, don't write it now. Just look at product rule. Tell me what you there, Shavish. Huh? Look at the whole thing. 2x plus 1 multiplied by cos x. Right? So u is 2x plus 1. And v is what? Stop telling Mariana. Yeah. U is 2x plus 1. So what do you think would be v? Finish? One minute. Recalibrate and print.
这个时候算90是不是90分？I think it's in 15 minutes less.
Question said people said 75 minutes.
Yeah, but
I know.
it's just 10 minutes. Let's try that.
You're 9 minutes a month. I would. Yeah, Shabish, where's V? So this here is your U and this here is your V. Right? So your V is cos X. Right? Elena, what's the differential of U? What's the differential of 2x plus 1? 2. What's the differential of cos X? To mark the page range, just do the thing. Minus sin X. Okay? Now we can use the formula. dy dx is equal to, what's the formula? U multiplied by dv dx. So that's 2x plus 1 multiplied by dv dx, which is minus sin X. Then we multiply in v, which is cos X, by du dx. And that's it. We're not moving on from there. No factorization. Leave it just like that. Right? So you can leave it just like this. Put the minus sign outside. And then you can put it 2 in front. Right? Once you identify u and v, plug it in the formula. Take a 2-minute break in your head. Well, take a 2-minute break and then we're going to try quotient rule. That's the last thing in differentiation. Application. In being able to differentiate. No applications, right? We're not doing any application today. Right? So that is your product rule. Once you identify 2 products, you work it out, right? Right, 2 minutes up. So on your own, I want you to try quotient rule. Of course, I'm telling you quotient rule. So in fact, before you start, just to make sure people pick the right thing. Which one is U and which one is V? Which one is U, Shavish? That's why I take it right, Shavish. I'll ask them after you. Which one is 2x plus 1? Sorry. Which is U and which is V? All right, go ahead. Use the formula and work it out. Take your time now and simplify this one out, right? So write down U, differentiate U. Write down V, differentiate V. Plug it in the formula. Right? Write down U, write down V. When you write it down, differentiate it. Formula right there on top of it. Quotient rule in. One. Any wrong formula, silly. All right, so let's see what you have for you. So U is equal to 2x plus 1. V is equal to x plus 1. Du dx is 2. dv dx is 1. Right? So I'll come back to this formula here. And I will get dy dx is equal to v, which is x plus 1, by du dx, which is 2, minus u, which is 2x plus 1, by dv dx, which is 1, all over v squared, x plus 1 squared. And you multiply it out. 2 by x is 2x. So that's 2x plus 2 minus 2x minus 1, all over x plus 1 squared. Okay, so that's equal to 2x minus 2x is 0, 2 minus 1 is 1. So it's 1 over x plus 1 squared. No, leave it like that. Yeah, leave it like that. So it's 1 over x plus 1 squared. Okay, so that's a quotient rule, that's a product rule. All right, I'm giving you one more. One more, and then we could look at integration. There's a lot here. I want to watch over this video and do over this. All right, there's a lot. Right, once you can differentiate and integrate, then we could go into the applications. All right, most likely I'll spend a lot of time on kinematics, right? With just side income. Oh yeah, like you online. Right, so I want you to try this one. You tell me, you figure out which rule it is and differentiate it. Right? You figure out which rule and try to differentiate it. Everybody writes in? All right, so watch here. All right, I was going to give it tan x, but I'll just help you out, right? Find the differential of sine x over cos x. Choose the right rule and work it out. Simplify it out, huh? Find the differential of sine x and cos x. I'm giving it 3 minutes and I'm passing around. Those who are online, try and simplify it, right? Before I send the answer. Which rule are gonna use here, Zane? Product of quotient. Which one? Quotient is the CT factor. Quotient rule, right? Oh yeah, use the rule. Right here, try the question there, right online. Right, Karen going there earlier. I'm talking about telling online there. Right, current now go on there. Right, so y'all try it out. Naisha correct, Amanda correct. Do those who here are passing around, eh? Are passing around to what? Try it there. Turn on your light now. What? I will see all the working. Yeah, we still have time. Everybody have a little phone. Good. Very good.
And you can multiply and get that, right?
Yeah.
But just now you were saying something else about this.
No, that was different. That's not cos x by cos x.
So you can't
It's
do that.
cos, but cos x. Some different. Huh? What's the differential of sine? What? No, I use about the same rules from before. Yeah. I think I think give you some homework, my textbook, right? Plenty. Where you going, Elena? Come on, do the question. Hurry up. We have real time. Last one, we can wrap up. Anybody else have current around here? Check out what it's saying and the likes on.
Of course, it's a school day.
Next door.
Why not?
Yeah. Hurry up, work it up quick. Yeah, that's correct. Correct. All right, guys? Wait, what do you do there?
Don't worry about this. This thing on top of my head. Yeah, this over 1 will on cos 1 on cos squared. Yeah. So you can just use sine of cos squared as 1 there.
What do you mean?
Just write sine squared of cos squared as 1. Numerator. Higher down. Right, going good. Just plug this in the formula.
No.
No. What's the formula? B by du dx. B that du dx. There. So this by this.
Oh, this way, not.
Yeah, look at what I write here. Look at what you have there. I have B, that's a U.
Oh, so wait, what is yes or right?
Yes.
I can make a mistake here. And it's multiplied.
Yeah.
Cos x by cos x, so that's multiplied. And it's sine multiplied. So it will be sine, positive sine squared. Right, still work on numerator. Wait,